Everyone. Till now we have been looking at the formation of image and its property formed by a plane mirror. A plane mirror is the mirror whose reflecting surface is flat. Now we will take up the formation of image by spherical mirrors. Okay, so a spherical mirror are basically classified into its two parts. Therein we have two types of spherical mirror. We have concave and convex mirror depending upon their orientation and their reflecting surfaces. Right? So first we have a concave mirror, and the second type of a spherical mirror is convex mirror. Right? These two are the spherical mirrors. How do they look like? A concave mirror is a mirror whose reflecting surface is curved like this, but the reflecting surface of a concave mirror is curved inward. Okay, so this is the basic difference between these two mirrors. Whereas in convex mirror, this is also a curved mirror. It also forms the part of a sphere, but here the reflecting surface in convex mirror, it is curved outward. It is bulging outward. Whereas this portion is the painted part of this mirror. This is the non-reflecting part. So can you make out the difference? In concave mirror, this is the reflecting surface. This is the reflecting surface, right? Whereas in a convex mirror, this bulging portion, the bulging outward portion, this portion is our reflecting surface, right? Now let's define some terms which is associated with these two types of mirrors. Okay, so one by one I am defining. First we have pole. Okay, so where do the pole will exist here? So I told you already that these two are the types of spherical mirror, right? So in this we will have a pole right at the center of this reflecting surface, right? So this pole will lie at the center of this reflecting surface here in the middle, and same as in the convex mirror also. Pole is represented by letter P and it lies just right at the center pole. Second one will be our center of curvature. So as I told you, this reflecting surface of concave and convex mirror forms the part of a sphere of a curve, because these two are curved mirror. Here the reflecting surface is curved inward, here curved outward, inside and outside. So this center of curvature this curvature must be having some center, right? So if you will draw a curve right around this reflecting surface, you will find this reflecting surface will form the part of a curvature, and the center of curvature will lie at the center here. So this is our center of curvature. Same as in convex mirror also. Here we will have somewhere center of curvature, or here let us denote it here, center of curvature for convex mirror also, right? So like this. Center of curvature is denoted by the letter C here, and it will lie at the center of this curve. Correct? Now coming to focus. Then we have principal axis also. Principal axis. These are the terms which I am going to denote here for these two kinds of mirror. Okay, so if this is center of curvature, this is pole, then where will be the focus? So focus will lie just in between center of curvature and the pole, right? And if we will join this C and P with a line, if we will extend this line by joining this pole and center of curvature, then this adjoining line segment will become our principal axis. Okay, so this line which is joining C and P, this is our principal axis. Okay, for here also, let us join P and C. This is our principal axis, right? Now focus. Focus will be the midpoint of this line segment C and P. Midpoint. This is our midpoint. This is our midpoint. So focus will lie here. Focus is denoted by the letter F. Okay, so very often this focus is also represented as half of this radius of curvature. Radius of curvature is the line segment which is joining the center of curvature and the pole, right? So half of radius of curvature is our focus. So you see here F is lying at the midpoint. Here also F is lying at the midpoint. So this is about focus, center of curvature, pole and principal axis, right? We have one more term for this two mirrors, that is the aperture. Aperture is the region or the area which is exposed to light. Okay, so at whichever portion in these two mirrors, the reflecting surface onto which the light falls, or the region of the reflecting surface which is exposed to light, that is known as the aperture. Okay, so this was all about the terminologies which is associated with concave and convex mirror. One more thing is that concave mirror is very often termed as converging mirror, right? This is also known as converging mirror, and this convex mirror is also known as diverging mirror. Diverging mirror. So let's illustrate this also. How come this concave is converging and convex is diverging? Let us see. Concave is a converging mirror because all the light ray or the beam of light which is falling on the reflecting surface of a concave mirror, all the light after reflection converges at a point. Converge means to get collected at a single point, at a particular point, right? So let us draw a concave mirror. So this is our concave mirror, this is our painted part or the non-reflecting part, and this is our reflecting part onto which the light ray will get incident, right? So let us draw the points also. This is our which point? Pole. This is our focus. This is our center of curvature, and this is the principal axis. I need not to write here. Now converging mirror, I am going to show the convergence of the light ray which is incident on this reflecting surface, right? So let us take parallel beam of light. These are the beam of light which is falling on this mirror. Okay, these are the rays of light. Now as I told you that when the light rays are incident on the reflecting surface either of a plane mirror or of a spherical mirror or any kind of mirror, that will follow the law of reflection. First of all, there will be reflection, that is the bouncing back of light will take place, and after reflection the light will either converge or diverge depending upon the reflecting surfaces. Surprisingly, you will find that all these rays will pass through focus. Okay, so if I consider this ray, so this ray will pass through focus. Okay, this is reflecting. This ray will also pass through focus. This will also pass through focus. This ray will also pass through focus. So you see all these rays after reflection are passing through which point? We found all these rays are meeting each other at the focal point at this point which is known as focus. And the converging, here the light ray are getting collected, they are getting converged at a one point. That is why this mirror is known as converging mirror. Here, now coming to diverging mirror, that is the convex mirror. Okay, so let us draw a convex mirror. This is our convex mirror, this is the non-reflecting part, and this is our reflected part. So here also let us take all the points first of all. This is the principal axis. Okay, we have nothing on the painted part, so we will just take the point on the reflecting surface. This is our pole. Let us write P here. This is our focus. Let us write focus here, and this is our center of curvature. Correct? Now parallel beam of light are incident. These are the parallel beam of light which is falling on the reflecting surface. Now after incidence, after getting incident on this surface, all the light ray will reflect back. They will bounce back, but there will be divergence. Correct? So if I take this ray, if I take this incident ray, then this incident ray will diverge along this direction, right? So here we will extend back this reflected back in backward direction, and it will appear like if the light is coming from behind the mirror. Same for this ray also. This ray will also diverge along this direction. Okay, along this direction. This is the reflected ray, but reflected ray is not coming from this surface, from this point. It is coming from this point, and it appears. Okay, so you will find like all these rays are meeting at this point, and that point will be our focus. But focus will be behind the mirror, okay, at the non-reflecting part, and this will be the virtual light rays. Okay, this is not the real one. These rays are intersecting, not in real. That is why in this case, in the case of convex mirror, the nature of the image which is formed on this in this case will be virtual. Correct? But you see here actual intersection of light is taking place after reflection. So in the case of concave mirror, the nature of the image will be real.